All right, in 11.2, we're going to perform a hypothesis test about the mean difference between two samples where we have matched individuals from one sample with someone from the other sample. It can be items, it can be people, it can be the same person. You can be matched with yourself. That's often done in a before and after kind of study where you have the same person and you measure something or find out something about them before, and then you try a treatment on them or something like that, and then you check after and you match the results for that person with their results from before. So in this one, these are dependent matched pairs. The notation is mu sub d. This is the mean value of the differences for the population of paired data. So each pair generates one number, and that is the difference between the two of them. The difference between the before and after measurements, the difference between the husband and wife in the number of cups of coffee that they drink, the difference between the two siblings in, how fast they can run, whatever it is you're measuring, they're paired up together. And each pair generates one measurement that is the difference between them, and we're looking for the mean difference of all of the pairs. D is the individual difference between two values in a matched pair. D bar is the mean value of the differences for the sample data. So this is for the whole population, the mean difference. And this is the mean difference in the sample. And S sub D is the standard deviation of the differences for the sample data, and N is the number of pairs. Remember, these are in pairs, so the two samples have to be the same size because they are matched up. One on one. You can't have different number in each of them or someone wouldn't have a match. The requirements are the sample has to be obtained by simple random sampling, or the data has to come from a matched pairs designed experiment. The sample data are dependent matched pairs. The differences are normally distributed with no outliers, or the number of matched pairs is large and greater than or equal to 30, that 30 that we've used before, so that we don't have to necessarily know if they are normally distributed. And the sample values are independent. Because they're matched samples, remember, the samples have to be the same size. So the hypotheses, first of all, the null hypothesis is that the mean difference is 0. The average of all the differences for each pair is 0. And the alternative hypothesis is going to be that the mean difference is not 0, it's not equal to 0, or that the mean difference is greater than 0, or the mean difference is less than 0. So we use these two when we want to say that one group has a higher value than the other group, like husbands drink more coffee than wives, or one sibling in a matched pair, the older sibling runs faster, or something like that. If you want to say that one is greater or one is less. If you just want to do a hypothesis test to see if they're different, you would choose this one. In this one, we are going to look at the test statistic and the p-value, and those come from the calculator. We just perform a t-test, and remember, this is the same test that we performed for the mean in Chapter 10 when we were doing a hypothesis test on a single sample for the mean. We're going to use that same test because, like I said, we don't really deal with two sets of data here. In the end, we test on just the difference. So like if you had husbands and wives and you were looking at how many cups of coffee they drink, do husbands drink more coffee than wives, or vice versa, you would have the difference between the number of cups of coffee, there would be one number for each pair. So like if husband number 1 drank 6 cups a day and wife number 1 drank 4 cups a day, their difference would be 2. They have that one number for the pair of them. And that's important because then we end up with one list of numbers and we can perform a t-test. So in the matched pairs or the dependent pairs, Each one has one value. Make sure you remember that. And how we put it into the calculator is we have to kind of go through a few steps. It's not hard, but I'll show you how to do that. And so we put the list of one of like the husbands or the before or whatever, the before data in L1. We put the other list of data in L2, and then we go to L3 and make it do the subtraction so that we just perform the test using list 3. And that is the list of single values that represent the differences between, say, the husbands and the wives, or the before and the after, or whatever we're testing. And it's really important to remember this, because getting this right, if you're doing greater than or less than, that can be tricky. So remember, if you want L1, you want to label what's in there. If L1 is husbands, or it's before, or it's whatever it is that you want L1 to represent, make sure you label it. If you want L1 or think L1 is bigger than L2, in other words, in the alternative hypothesis, if it says that whatever this is bigger than that, then you want the mean difference to be greater than 0. Because if on average the first ones are bigger, remember when you subtract a smaller number from a bigger number, you get a positive number. So this is saying on average the differences will be positive if the first numbers are bigger. And it's just the opposite here. If you want L1 or think L1 will be smaller than L2, you're going to use this as your alternative hypothesis, because if the smaller numbers are in the first list, then when you subtract, on average, you should get negative differences, because the bigger number is the one you're taking away. So that's an important thing to remember. Let's look at an example. Remember, we're going to do a t-test on list 3, and we'll choose data unless we have statistics for both groups, and you might have that in an example. You might be given some of that, but we're on this one, we'll have data, and we're going to put this into our lists. So in low speed crash test of 5 BMW cars, the repair costs were computed for a factory authorized repair center and an independent repair center. Is there sufficient evidence at alpha equals 0.01 to support the claim that the independent center has lower repair costs? So this, and remember, this is a very strict alpha. So we're going to put these in. We're going to put the authorized repair center in list 1 and the independent repair center in list 2. And first I'm going to clear my list, so I make sure I'm not putting it in on top of other data. So remember, second, and then the plus sign is the memory, and I want to clear all lists, so I do 4. And we haven't used our lists in a little while, so you might have forgotten some of that. And now I want to put this data into the 2 lists. So I go to Stat, and then just hit Edit, and I'm going to go over here to List 1. I'm going to put these in. So 797, 571, 904, 1147, and 418. So I have those in there, and then these others I'm going to put into List 2. So 523, 488, 875, 911, and 297. So I've got them in there. Now I want list 3 to calculate the difference, and this is how I do that. I go over to list 3, and then I arrow up until I'm in the little title bar. And remember that the lists are above these keys down here, so I want it to choose list 1 first, because I'm going to subtract list 1 minus list 2. So I do second 1, and see it's got list 1, minus second 2, and because it's up there, when I hit enter, it'll subtract all of these for me, and you'll see it'll fill it in. Voila. So now I have a list of the differences, and I simply perform the test on list 3. I don't have to worry about list 1 and list 2 anymore. These are the differences, and we're looking at, on average, are these differences 0? Now, because of our really strict alpha, we may not get the result that we might expect, but that's the way these tests go. So I'm going to quit, and I'm going to go to my tests. So Stat, tests, and I just want a t-test, which is number 2. And I'm going to put in data because I've got these in the lists, and I'm going to perform it on list 3. My mu naught is 0, so this is how we set up our null hypothesis and our alternative. Now, we're looking to see if the independent center has lower repair costs. So that's number 2. So remember, if we think L1 is bigger than L2, we choose this. We think that the authorized repair center is more expensive. So the claim is that the mean difference is greater than 0, and the null hypothesis is that the mean difference is 0. There isn't a significant difference in the costs. And alpha is given as 0.01, and I'm going to conduct this test, and you can see what I've got in here. The mean difference is 0. The list that I want to check is list 3. The frequency is 1. I'm choosing a right tail test because that's my alternative hypothesis. I go down here and calculate. And you can see that our t is our test statistic is a t-value, so it's 3.21, and our p-value is 0.016. And even though 0.016 is pretty small, it's not smaller than 0.010. Think of this as, you know, if you look at the 0 is the same, but then this is a 16 and this is a 10, this is bigger. It's not a lot bigger, but it's bigger. So P is not low, so we do not reject H naught. And when we do not reject H naught, our conclusion is that there is not sufficient evidence to support the claim that the independent center has lower costs. So that's our result there.